Today we're going to be talking about how to multiply and divide rational expressions, which is a continuation of our series exploring rational expressions and functions as a general concept as it pertains to Algebra 2. Now this topic is fairly standalone. You're not going to be doing any graphing or any asymptotes. You're just going to be multiplying and dividing these types of expressions. So let's go ahead and jump right in. I am assuming that you are familiar with the skill of factoring, however you choose to do it. Maybe you do the slide and divide tactic. Maybe you have ways of drawing diamonds and boxes and your own methods of factoring, but I am going to assume a strong familiarity with factoring. So let's go ahead and begin. Take a look at what we are being asked to do here. Multiply these two expressions and then determine the domain restrictions. We are multiplying, so we can ignore this little dividing situation here. And let's just go ahead and begin by factoring. That denominator is going to factor into x minus 8 and x plus 6. The numerator on the other part of the expression is a difference of squares, meaning the result from factoring is going to be a pair of conjugates that you can see right there, and you would just take the square roots in order to fill those in. I went ahead and linked a video discussing factoring as it pertains to Algebra 1 if you need a review on some of these factoring skills. Moving on though, we can now start to rewrite the overall expression, taking the denominator and numerator and rewriting them. And then the other parts of the function are just a 7x and a 14x. So you can separate those into their own factors just like that. And now we have factored, and now we are ready to simplify. So cancel out all the things that can be canceled out. 7 goes into 14. 2 times. You have an x plus 6, you have a single x. All of that can be canceled out. And now rewrite what you are left with, and you can set up your final answer with both the expression as well as your domain. So first, take a look at what we are left with. An x minus 6 from the numerator is now there, and then the denominator had a 2, so that's in the denominator, and then the x minus 8 is also there in the denominator. So that is where the answer came from. Now take a look at your domain. Because we canceled out a x plus 6, then that means x equaling negative 6 is going to be a removable discontinuity. That cannot be in the range. Because we canceled out a single x, which, according to the zero product property, you would just do x equals 0, just like x plus 6 equals 0, and you would minus 6 from both sides. It's the same idea. It's just a single x by itself. So that is representing a removable discontinuity of 0, because originally that x would have said x plus 0, but you don't ever write it that way. Basically, just if you're canceling out an x, that means 0 cannot be in the domain. That's the main idea. And that is the answer. That is all you're doing to simplify these expressions. You factor and simplify so that you can get a single expression just like that, and then you establish the domain by looking at what you canceled out and what values cannot exist in the denominator. So we have an 8 right there because it said x minus 8 in our final answer. You can't plug in 8 because 8 minus 8 would be 0, and you can't have a 0 in the denominator. Let's do the next problem with a little bit of division, which is going to start off with a little bit of keep, change, flip in order to rewrite the problem. Notice how what we have here currently has a division sign. We're going to start by changing that division to multiplication. We are then going to flip the second expression. And now we have done keep, change, flip. You keep the first expression the same. You flip the division sign to multiplication. Oh, not flip. Change to multiplication. And then you flip the second expression and move on from there. Now the rest of the problem is what we were just doing before with factoring and simplifying. We're going to go ahead and take the first numerator and do the slide and divide procedure. Take note of the fact that we had to start off by sliding the number 2 into the 15 in order to give us a 30. You would do this with multiplication. And then notice at the end of the problem, after you get your binomial factors right here, you have to again divide by that number 2 that you initially slid. And since 5 is not divisible by 2, the 2 slides back to the front of that part of the expression, and 6 divided by 2 is 3, so that's why you see the 3 right there. Again, there's a video link that will go into that procedure a bit more. Do the same thing to the other expression's denominator with slide and divide, or whatever factoring method you prefer, and this is what you now have. Take the 3x and write it as 3 times x. Take your other denominator and factor out the GCF, which in this case is also 3x, and rewrite your new expression. Do this every time to stay organized before you start canceling things out. This is what you have after everything has been factored. The first numerator right there has been factored. We have this denominator factored right there. We have the 3x appearing right there. And then the last denominator, we factored out that GCF right there. I am assuming you know how to factor and simplify. So let's now cancel things out. Whole lot of things go away. You are left with just the x plus 3 from the numerator appearing right there. We have the x plus 1 in the denominator and the x minus 4 in the other denominator. So there's your final expression. And let's take note of the domain restriction. So the 2x plus 5. When that canceled out, that is giving you the domain restriction at negative 5 over 2. Once again, the zero product property comes back. You would take 2x plus 5, and you would set that equal to 0. Subtract 5 from both sides to get that. Divide both sides by 2, and you would have negative 5 over 2. So that means the domain, there would be a removable discontinuity there at negative 5 over 2, and negative 5 over 2 cannot go into the domain since it would make the denominator 0 with the zero product property. The x that you canceled out means 0 cannot be a solution. And then the x minus 4 and the x plus 1 gives you the negative 1 and positive 4 because those are left over in the denominator and they cannot be equal to 0 if you were to plug negative 1 and 4 into that final answer. A lot of this was talked about in the previous video, so I am moving kind of quickly to keep things moving along. Basically, just to recap, you do keep, change, flip because we were dividing in this problem. You factor and simplify the entire expression, and then whatever's in the denominator, you can't have those opposite numbers be in your domain. Whatever you canceled out, those opposite numbers can also not be in your domain. Here's one to practice on your own. Pause the video and try to do a little bit of keep, change, flip. Also do the domain part. And here's what that answer would look like. You would start by factoring, let's have that animate a little bit. You would start by factoring both of your expressions by doing the factoring skills. So here is the work for doing that first piece. And then you can go ahead and start simplifying things. So your m minus 1s, your a minus 4s all cancel out. And this is what you're left with as your final answer. And since you canceled out a negative 4, then positive 4 cannot be in the domain. It's a removable discontinuity. And then negative 1 for m, or m minus 1 was also canceled out. So that's why m cannot be equal to the number 1. And then the 7 is appearing there because in the final answer, you have an a minus 7, meaning positive 7 would make that domain, that denominator become 0, and therefore positive 7 cannot be included in your answer. Here is one more situation you might be in where you would see a fraction sort of within a fraction. And don't be intimidated by this. It's very easy to rewrite. Notice, which I just highlighted, that the fraction bar in the middle is showing you that the numerator and the denominator are their own separate expressions. Think of the top part of this superfraction as your initial part of your division problem, and then the division sign can be rewritten from the fraction bar, and then what is in the denominator can just be moved next to it. And now this is a keep, change, flip problem. It is the exact same polynomial rational expression that got written right here. So what you could do right now is actually pause the video and see if you can finish this situation up to make sure you got it. But let's just go through it again anyway. Do a little bit of keep, change, flip. Division sign becomes multiplication. Flip the second expression over, and then start your factoring procedure. Factoring gives you the following expression. So your denominator becomes x minus 6x plus 2, and then the other expression factors into what you can see here. And then start canceling things out. You're left with x plus 1, and then the x minus 6s are in the denominator. Again, I went fast because we've done a few of these right now, and a lot of these factoring and simplifying skills were talked about in the first video of this series, so please go back and look at some of those factoring skills if you need a little bit more practice. And feel free to drop any comments or questions so that I can give you a hand. Here's one more practice problem using keep, change, flip again. Oh, it does say multiply there, but that should say divide. And here is that solution. So you would do some keep, change, flip, and you would get the following answer that you see up here in yellow. Thank you for watching. Please let me know if you have any questions, and I will see you in the next video.